So here we come to IGCSE Mathematics Paper 4, Specimen Paper 2020, the last question, number 11. So for 11A is about the turning point. Oh, it's about the differentiation, right? Let's look at that. Oh, it's order of 3, so you can't use the computing square method. So you can just use the differentiation to do this. Before we go, let's take a look on the differentiate problem. If it is like kx to the power n, if k is none of the business of x, just a constant, so what do? We just put it outside. And then for the index of x, you just put it outside again, right? Just like the log form. Right? So you take it outside, but when you take it outside, the degree will decrease by 1. So this is that. So for example, if you want to the 3x to the power 5, it will be like equals to 3 times the 5, and then x to the power 5 minus 1 will be 4. That's it. Okay, so we can just use this to differentiate this whole thing. So we did it separately. The first thing, the red one, will be equals to 3 x to the power 2 decreased by 1, and then the next one, the blue one, will be -6 first, or the constant out, and then the index 2 times 2, and then the degree decreased by 1, so it will be 1, but 1 normally we won't write it, right? And then how about the green one? The green one will be something like, you can think it this way, as a 16 times the, actually there can be a x to the power 0, so you can multiply it by 0, and then x to the power 0 minus 1 should be -1, like this. But you can see, all right, you have 0 here. When you multiply anything with 0, you got nothing. So normally we just delete this one, right? So for any constant term, when you differentiate it, you will get 0. So you can just remove this one whenever you just got a constant term. So this will be the answer. So let me write this way. So it should be 3x squared minus 12x. So if you want to find the turning point, we need to set the dy over dx equal to 0. So we need to set this one to 0 and then get the x. So that's it, and 3x squared minus 12x equals to 0. I will just use the factorization method. So I will get 3x times x minus 12, x minus 4 will be equal to 4. So 3x is equal to 4, or x minus 4 equals to 0. 3x equal to 0, sorry. So x will be 0, or x will be a positive 4. But we are not, we didn't end here, because we need to find the y value. Alright, so we get that the turning point must be at the x is equal to 0, or at the point x is equal to 4. So and then what we do, we just substitute the x to the y, and then you can get the point. So when x is equal to 0, so x is 0 and x is 0, like this, and using the calculator, you will get that y should be equals to 16. Right. And then when x is equal to 4, you just pop it into here. Okay, so y should be equals to -16. So there's 2 points. The first point is when x is 0 and then y is 16. And then the second point is when x is 4, y is -16. So remember, you can't put it like 0, 4. Remember, each x is correspond to each y. So here we come to the final part, B, of the question 11. So finding the maximum or minimum point. Okay, so you can have 2 methods to do it. The first method is using the second derivative. So before that, we already get the first derivative in the part A, right? Like this. And when the second derivative, when we substitute some x into the second derivative, and then we give some positive thing, alright, then the A will be the minimum point. And when we substitute the x into the second derivative, and then we get some negative thing, then A is a maximum point. Or you can use this one. But anyway, you need to have the second derivative first. So let's start from the second derivative. So we just did the first derivative to get the second derivative. So this one will get you 3 times 2 times x to the power 1, right? And then minus 12 times 1 times x to the power 0. So you can think about this way. So 1 and x to the power 0 is 1. So actually it's just 12. Okay, so you got 6x minus 12 as the second derivative. So we just substitute something. When x is equal to 0, let's see, we'll represent it this way. When x is equal to 0, this will become 6 times 0 minus 12. So we'll get a negative 6, right? So it is less than 0. So we can have the conclusion that the 0, 16 is a maximum point. All right. So similarly, let's get the other one. All right. Let's substitute x equal to 4, and then we will get 6 times 4 minus the 12 will be equal to 12, right? All right. So it is a positive. It's higher than 0. So we can get that the 4, negative 16 is a minimum point. So this is the first method I will do. So using the second derivative. For the next method, we don't need to calculate the second derivative. We just use the first derivative to finish it. Think about the range of the first derivative. But first of all, we need to separate it into 5 areas. So how do we separate it? We use the x value, the 0 and the 4. And then this will cut it into 5 different areas. The first area is the x is less than 0. And then the next one is x is equal to 0. And then the next one will be the green area. X is in between the 0 and 4. And then fourth, we have the x is equal to 4. And then finally, we got x is larger than 4. Okay. So we have a table like this. Okay. So we have 5 range. But for x is equal to 0, we want to find that in this 5 range, the corresponding first derivative, that's the dy over dx. Is it a positive, a negative, or a 0? So first of all, for x is equal to 0, we have already calculated that it must be 0, right? The d. And then for when x is equal to 4, it must be 0 too. And then, so how about this? When x is less than 0, the first derivative, is it a positive or negative? So we just pick any number that satisfy x is less than 0. So I will just pick x is negative 1, and then we substitute the x is negative 1 into the first derivative. And then using the calculator, you will get, it should be a 15, I think it's a positive 15. Alright, so anyway, it's a positive one. So it is a positive. I'll just put a positive here. And then we think about the green area. So again, I will just try any number within this range. So I will just pick 1, or to make it simpler. So put a 1 here, and then you will get a negative 9, I think. So anyway, it's a negative, right? So and then for the yellow thing, when x is larger than 4, maybe I will just use a 5. Or I will substitute x is equal to 5, and then you put it here, 5 square times 3, and minus 12 times 5, so it will be positive 12. So anyway, it's a positive. Alright, so it's a positive, and you should know that when the curve, the gradient, the slope or the first derivative change from positive to 0 and then to negative, this must be a maximum. And while on the other hand, when it changed from a negative slope to a 0 and then to a positive, this must be a minimum. So actually you already showed that when this from a positive to negative, so this must be a maximum. So you can also get this, or 0 when x is 0 and then y is 16, it is a maximum point, and from the negative to positive, it is a minimum point. All right, so this is really the end.